Okay, so today is the day 6, lesson 6 video recap for designing tsunami warning systems. So, what we're going to look at is I know that you started to use the sim already. You've already kind of analyzed that our our different sensors belong in different areas. So the E is earthquake sensors. Those generally belong on land near a plate boundary or near a fault line. The S stands for shallow water sensors, and those are best at the light blue waters. The D stands for the deep water sensors, and those are best in the darker blue waters. So hopefully yesterday when you were working with the sim, you learned a little bit about what is a best practice for placing your sensors. So I'm going to remind you that you access your Futura workspace through the blue link in Amplify. And today you're going to start designing your tsunami warning system. Yesterday we played with the sim and we analyzed and we looked at what the cause and effect relationships were. But today we're going to actually start designing that warning system. And we're going to look at a design cycle to see how we go about improving our designs. So here we go.
The design cycle is a process used by scientists and engineers to create solutions that address specific goals or criteria. The design cycle has 4 main steps: plan, build, test, and analyze. These steps form a cycle that repeats. Typically, you begin with plan. In this stage, you think about your criteria and make a plan for a design that meets those criteria. On the build step, you actually start creating your design. Once the design is built, you test it. The test results give you information about how well your design works. Next, on the analyze step, you examine your test results. How well did your design measure up to your criteria? Here you figure out whether there are areas that need improvement. Finally, you're back at plan. This is when you think about what you can change in your design to better meet the criteria. You will go through the full cycle over and over until you have addressed the criteria as effectively as possible. Just remember, your goal is to improve your design each time you move through the cycle.
Okay, so as we go through the design cycle, hopefully we learned different things such as in the plan step, engineers think about specific research they've done and the project criteria. They make a plan for a design that applies their specific understanding to address those criteria. In the build cycle, in the build step, engineers create a design. In many cases, engineers build or use models rather than the actual product, so they can make quick changes to their designs. Some models are small, physical replicas, and others can be computer-based. For this internship, you are using the Tsunami Alert design tool, the SIM, to build and test models for your designs. In the test step, engineers run the test to get the results. These outcomes help engineers figure out how well their design works. In the analyze step, engineers carefully examine the test results. They consider how well the test results address the project criteria and identify areas that need improvement, sometimes by comparing versions. Based on the analysis, engineers return to the planning stage. They think about what they can change in their design to better address the criteria in their next iterative test. In this way, engineers progress through the design cycle multiple times. So there's our iterative testing. And with that, we want to make sure that we are improving in each new trial, but I do not suggest changing everything all at once, because it is important in science with a scientific method to change one variable at a time. So if you were, let's say, to change one sensor, see the outcome, make a test, analyze your results, and then make another change. I would not suggest starting over for each trial to replace all new sensors. So you will use the Tsunami Alert data collection slides. So this is what a preview looks like. You have Google Slides that I've attached to Google Classroom for you, and you are going to gather your data there. So let's go ahead and watch a demonstration of exactly how we are gathering that data.
Let's review how to record your Tsunami Alert designs and test results on the Tsunami Alert data sheets. On each sheet, there's space to record 2 versions. Remember to write the version number for each iteration so you can keep track of them all. Under Plan, you'll write about the design idea you'll build and test. Here, you'll explain the strategy that you'll use to address the criteria. Under Build, you'll record the number of each sensor type you use. You'll also list the coordinates where you place the sensors. Mark the earthquake mode too. Unless your internship coordinator tells you otherwise, keep the earthquake mode set to random. That's because it's impossible to predict exactly where earthquakes will strike. Now, you're ready to test your design. Press Test. The test results will show how well your warning system functioned over a simulated period of 50 years. You'll see some randomness in where the earthquakes occur, which will affect your results. Under Test, you'll record the average warning time, whether all necessary warnings were received, the number of false alarms, and the total 50-year cost. Under Analyze, explain what your test results mean. Think about ways your design was successful, and ways it could be improved. You can record additional details if you decided to use the Study Earthquake feature, or if you ran multiple tests for the same version. Now, you're ready to make a plan for your next design. For example, you can write about what you'll change in the next version. Press the Edit button to start making your next version.
Okay, so that helps us figure out exactly how we are going to gather our data. So here's an example. So in this example, we can see what the plan, and start thinking about what the plan might be for the next version. So I'm not going to make necessarily a suggestion, except for that I would move only one sensor at a time to determine what will make an improvement, or which one sensor you're moving, whether that makes the outcome better or worse. So hopefully there's no questions about the Tsunami Alert data sheets, but I do want to just remind you, you're putting your plan number in, you are doing this on a Google slide. So Tsunami Alert, if you do have any questions about how the Tsunami Alert works, you can watch the video from yesterday in which I explained the Tsunami Alert system. You should test 4 to 6 different versions of your design. Record all your results, even the weak results, in your Google slide, because you can learn from what doesn't work. While you're evaluating each design, these are some questions to think and keep in mind. How well did each sensor perform? What were the warning times for each ocean-wide tsunami? If the warning time was 0 minutes, how can you improve it? If there were false alarms, what can you do to prevent them? As you analyze tests, you'll need to look for patterns in the data, such as what changes make your minimum warning time go down and what causes decreases in false alerts. It's really important to only change one sensor at a time so that you can see what is having that cause and effect relationship. So you'll decide which criteria is your top priority, whether it be to, minimize false alarms, maximize warning time, or keep costs low as you plan your strategies. So you're going to build and test 4 to 6 versions of your tsunami warning system. You're going to analyze each version before you plan the next and record your data. And that is the end of today's lesson recap.